G'day champions, it's been a while. Let's get back into a video binge. First cab off the rank, as I say, is a Focusrite Preamp. It's a ISA428, so that's a 4-channel mic pre with a digital board, and it's got optical output there as well as word clock, and your analog inputs and outputs over here. Now, this unit has come in with crackling and popping, so I opened it up and found various cockroach carcasses in there, which is always fun. And you can see here, lots of cockroach poop, so that's fun. It's not only in amplifiers you see this stuff, anywhere nice and warm they like to hang out. So chances are we've got some conductivity happening in that fecal matter. Oh, that's so fun to say. I haven't found any damage or anything in the analog circuitry area. It's mainly restricted to the digital board. So it's like they got in through a vent and had a little party until they carked it. So luckily there's no damage. I'll have another close look, but in my earlier inspection there's no damage down in this little city of super dense componentry. So this is the input transformers. Has got relays for various things like pad switching and gain levels and stuff. You've got some optos over here. These boards are beautiful boards because they have little, you can see on the silk screen, there's little zones, and then it tells you what each little zone is. Like, how good is that in 2022? Channel 5 to 8 ADC limiter and input, so you know that that's channel 5 to 8 ADC analog to digital converter limiter and input, and then channel 1 to 4 same there. It even tells you the little channel banks. And then down here you can see mic line 1, mic line 2, 3, 4, so they're the input channels. And you've got VU meter overload drivers down the bottom there. Relay drivers here, so a bunch of chips driving the relays, controlled by the microcontroller, which is housed underneath there. So we'll remove this board and we'll set that aside for a good clean. Just inspect the other side of it. So it's got a Xilinx Spartan brain, local regulation. And looks like some rework. No, we don't, we just pretend to. Looks like some rework has happened in this area at some stage, because we can see some flux on the board there from some rework, and there's no flux anywhere else on the board. So there's every chance that was executed fine and wasn't an issue, or maybe they were chasing something else and removed some components to eliminate a possibility there, but there was no reports of any issues with the digital option, so we'll leave it at that. Just give it a clean. So you can see here, you've got your word clock in and out, and you've got your different channels, so 1 to 8 at 48 kilohertz, and as you go up in the frequency you get less channels. It's the same bandwidth. So let's put that aside. We'll have a look underneath. So pretty simple processor on this one. You got a small, I believe that's a PIC processor down there, and it's got the label on it. The label has its program from Focusrite written on there, and then it's got its little memory chip next to that it's talking to. Next to that you got your crystal to provide the clock, and then you've got your power supply, which is up in the corner, and that's an area we're going to be focusing on, and a common issue for these units. So there's some bodge wires here that disappear off to the meter board here. There's a aftermarket board mounted 90 degrees on a bracket, and that's to offset the meters to center them, basically to calibrate the meters. It looks like maybe that wasn't thought about initially, and that was an addition at some point, but pretty early in the production, because it's in every unit and it's got a factory made bracket and circuit board there. So we'll remove this cable that's coming from the secondary of the transformer. Sounds a bit scritchy there. It's not a good sign. The old overheated Molex connector. So those contacts look pretty dirty in there. They're probably a little bit oxidized from overheating. Just another case of ignoring the current rating of a Molex connector. Everyone does it. You're not cool unless you do that. Mesa Boogie do it. Everyone does it. If you're going to... it's a bit difficult in that case because it's coming straight from the transformer, but if you're going to expect higher than rated current from a connector, just parallel that 5 or 6 contacts together, or 3 or 4 contacts, whatever it takes, to get the combined current shared between them, and then it won't be an issue. But no one does that. So what happens with these box connectors is they, the IDC headers, is they love to take that little box with them when you remove the plug. So you need to just hold that in. Don't know why I'm giving you tips. It's probably like 1% of people watch this actually work on stuff. So here's the power supply. We've got various regulators mounted on heat sinks, well, mounted to the chassis, which has a heat sink on the outside, a pretty paltry heat sink really, but anything's better than nothing, and the case is made from alley, so it will dissipate quite a bit by itself. Actually, I think that's, yeah, no, that's steel. It just has a nice coating on it. And then you've got your filter caps here. Now this one here is bulgy. Might be a bit hard to make out there, but it's bulging up by a good millimetre or so, and that's not great. Now that is hugging, well, not hugging, but it's pretty close to the bridge rectifier, and as you can see by this connector being burnt, this thing draws a fair whack of current. When you've got that many chips and digital stuff and an option board and just that many op amps, it all adds up, and then you multiply it by channels, and preamps draw quite a bit. If you've ever been in a recording studio with a large professional console with modular channels, you hold your hand above the mixing desk and you can feel the heat rising off it, and that's just coming from low voltage op amps, just an absolute shit ton of them. So when you scale stuff up, as you do with studio, when you multiply everything by the channels, the complexity increases exponentially. And so does the current draw. So units like this actually use a fair whack of current. So you can see here on the mains input, this unit draws 65 watts. That's quite a bit. That is about the same as a Fender Pro Junior valve amp. So it is significant. And here we've got it set to 230 volts, which is right, even though we sit around 245 here. What are we at the moment? 246, 245.9. Oh, what a guess. It goes up a little bit in the afternoons when all the factories switch off their stuff, but it sits around at least 240. It's pretty rare you see it under 240 these days, so that is a little bit high, but everything's regulated in here, so it's not that much of an issue. So what do we need to do? Well, we need to replace this cap, definitely. What I'm going to do is replace its mates around it with some 105 degree rated caps, a little bit higher in the temperature rating. That's only an 85 degree cap, and the smaller ones are 85s. I think we've only got 2 105s here, and they're jammy con. Well, we've got it out. We'll change them out to what's a couple of bucks for a few caps, and we'll do something about this connector, either replace it or clean it. It's not really lending itself to hard wiring. Just with how dense everything is down there, we won't really be able to get a soldering iron down there real efficiently. without damaging stuff. I would like to keep a connector, but maybe freshen it up. This unit is probably around at least 10 years old, so hopefully we'll get another 10 years life out of the next connector, but it's not a great choice using these things. And we're kind of locked into the form factor because that's what they put in the circuit board, so what do you do? So what would be brilliant, having done one of these before or a similar unit, is removing the back plate, leaving everything attached, removing the circuit board from the bottom panel, or that's a U-shaped chassis, and take the whole thing out without having to really disconnect much at all, if anything, because all of these wires can just hinge up. And we've disconnected the transformer, which is only connected on the secondary. There's no primary connections on the circuit board. All the fusing and stuff's part of that back housing I just showed you. And all the heatsink and everything's only connected to that rear panel, so we should be able to just unscrew this without having to undo all those connectors and all their fasteners, because that gets pretty time consuming. Pro audio stuff, a lot of the time spent just disassembling and reassembling the things. It is a bit therapeutic, I don't mind it, but when you've got 70-80 jobs in the queue, you kind of want to do it as quick as possible, right? So we'll remove this back panel and we'll swing the whole board up. So I've got a number 1 Phillips. Just making sure we don't ream the heads out. If you're working on Japanese stuff, if you've ever noticed, anyone that's looked at gear, you'll recognise straight away what I'm talking about. Screw heads that have a little dot next to the cross in the corner, they're JIS. I don't know what it stands for, but it's a slightly different geometry to the tip of the screwdriver. It looks like a Phillips sort of work in them, but they're a slightly different angle in the geometry of it. And ideally, you should have yourself a set of JIS as well, just to prevent any damage to screws. Oh, those circuit board screws are really loose, like someone's been here before. Oh, that one had Loctite on it, so heard that little crack. Might have just been a bit loose from the factory. So we'll just hunt for all the screws, make sure we don't miss any. There's always one hiding somewhere in the forest. This is where you've got them all, but there's one hiding. Alright, so that one on the BU meter calibration board's got to come out. That bracket's got to come with it. That's got to stand off underneath them. Where are we? One more. There we go. Hiding amongst the relays. Now this is a bit of computer equipment. Basically, it's got a microcontroller in it. So we're on the static mat here, anti-static mat, which is grounded. I could be wearing a wrist thing as well, and this chair is prone to creating static, but I'm resting on the mat, so that's fine. When you walk around on the carpet on a real dry day and you touch the mat, even though on a meter it doesn't really show any resistance, well, it shows infinite resistance, I should say, you still arc to the mat, so to 100,000 volts or whatever, 20,000 volts that are in your hand when you're walking on the carpet, the mat looks like a short circuit, and that jumps directly to the ground, which is plugged into our mains receptacle over there, just via the ground pin, and that grounds everything. Okay, there's one more screw hiding. Bit of a sneaky bugger down in that heatsink there. So you can, I should have noticed, because 1, 2, 3, 4. You know, if that screw was centralised, then I should have assumed it was the only one, but because it's not, we had another one hidden away. Alright, now we should be able to lift the whole assembly up. Just keep an eye on things, make sure we're not catching anything. There is a ground connection there to the chassis, which might limit us a little bit, so I'll remove that. Alright, so that's the bottom of the board. And again, they've got the silk screen there, and they've even got the description on the bottom silk screen of what area does what. So Very nicely laid out board. They're actually thinking about service, which is good because it's a pretty expensive bit of gear. Alright, it looks like a bunch of rework has happened here in this board's life. Hopefully we can see that. So you can see this row here is from the factory, that's all reflowed. And then here, someone's been in and done a bunch of stuff, not very well, and left all their flux behind. So that is channel 5 to 8 ADC limiter and input. And again, over here there's a bit of funniness happening over here as well. So I guess I could pull out the schematic and see what that's all about, but you really shouldn't leave flux behind like that. It's unless it's specifically designed to be a conformal coating afterwards. It can become conductive itself and lead to crackling and weird stuff, so not a good move. Some more rework here. I'll have to pull up the schematic and see what all of this is. It looks almost like they were trying to chase an issue and not really knowing what they were doing, but I don't know. I don't know the full story. I don't know why there would be this much rework to anything. But you know, what's a job in Brad's Guitar Garage without a bit of mystery behind it, eh? A bit of head scratching. There's a reason I'm going bald. And again, down here on the meter drivers, bit of rework there. Looks like maybe a chip's been replaced. Down here as well. Can't make that out as much on the camera, but I can see it here. Bunch of chips either been reflowed. Well, it looks like reflow work, because one side of a chip is done and not the other, unless they clean the flux off one side, but why would you? Oh, this is cute. When they've transferred the in the design software, when they've transferred the writing to the second side, they've forgotten to mirror the line of text in the middle for you driver. So yeah, when I design circuit boards, it's easy to copy from one layer to another, but you've got to remember to flip the bottom layer. And it happens to the best of us. Little bodge wire there. Either forgot to run a trace or the board was just too damn dense. This looks like a multi-layer board, probably 4 layers. Because you can see, let's try and find somewhere, yeah. So you can see, obviously the green trace is on top, and you can see the dark ones there. That's within the board. There's a copper trace. So you can't see them from the other side. They're actually within the sandwich board. So that makes repair and tracing very, very fun. In fact, not viable in most cases if something's gone wrong either inside the board or if you don't have a schematic and you're trying to trace the thing out yourself. Alright, so here's the bottom side of that connector. You can see it's discoloured around the area of those bad pins. And these little rings. It shows the solder joint. A little bit hard to make out with that light, but the solder joint's not really in good nick. So we can't just reflow them. I've got leaded solder here. We'll have to remove that lead-free solder and put some leaded solder. So we're going to get rid of all of it. To do that, I'll probably remove the connector just to check the other side of the pads. Just look at the thing closely, and it's also a bit easier to clean and inspect once it's removed. Here's the bottom pins for the caps. They're the large ones. And then you've got a series of smaller ones around them. So our big one that's bulgy is this one here. So we'll remove that and we'll just check that we've got some caps. They're pretty wide spacings on that, look to be 10mm. I'm not sure all of mine are that big, but I'll double check, and if we need to we'll order some. So we'll fire up the buffer. Nice and safe. Get the soldering iron out and angry. So first we'll put some new solder on there, new solder. Just to get the flux in there more than anything else. Get the flux out of the solder. Gonna need to up that temp a little bit. Excuse me. Not used to talking in the shop. Getting a sore throat. No, it's not COVID. Put some on those cap leads. Just ready to use the desolder gun. These are glued to the board, so I don't think they're going to come out without a little bit of a fight, but it just looks like hot melt glue, so shouldn't be too bad. I can't really blame you guys for seeing solder when paste say solder extractor SX100. For anyone wondering, a few people have looked at this gun and said, "What is that?" If you haven't got one of these and you're using braid, let's do a comparo, eh? I'll get my favourite braid. So here we've got Chemtronics number 6 solder wick. That's got resin flux in it. Let's see how she do. She do pretty well, but these are through plated holes, and the solder makes its way to the other side of the board. So without some suction, you're just not going to pull that solder out of that hole without overheating it. You can see there we've effectively removed the solder from the board, but the holes are still plugged with solder and the pin's still encased in that solder in the tube, essentially, that's the inside of the hole. So that's where all Sucky McSuckface comes into play. Put some decent amount of solder on there again. Just up the tip size. Only got the small tip on it. That suits just standard component leads. These are snap-in caps, so they've got a larger cross section to leads. It's come with a little handy dandy screwdriver slash tip remover. Undo the grub screw in the side there and pull the tip out with it without burning your fingies. So now we actually put the thing over the lead. Melt, move until you feel a lead move, and then extract that solder, and we've got a big empty hole there with a lead in it. And that's black all the way through to the dark side. So now, once that glue's removed, that's not too bad. Out she comes, right? Look at the other side. You can see where it was there. So that's the cap. You can, the bulge is more evident now. I've removed it. I can angle it around with the light. She's bulgy McBulge face, and that's that glue. That glue's not a great idea either, because it can become conductive. But in this case, it's not touching the leads, but it's touching the pads. So we'll clean all that off. And we might just use a little, I don't mind a bit of silicone from cap to cap to make them all like one body. That's fine, but I don't like anything really touching any contacts. Neutral cure electronics grade silicone's fine, but a lot of people will just use whatever silicone. So I advise don't let anything touch an electrical connection, and then you should be fine. To be honest, I I don't think I've ever seen a decent quality through-plated hole crack from mechanical movement. Having the snap-in leads offers a bit of mechanical support as well. And this thing's a bit of studio gear. It's not really going to be, you know, like a amp getting thrown in the back of your ute. So let's try the next shittest solder extraction technology, which some techs still insist on. One of these pieces of shit. So this one's probably one of the best pieces of shit. It's Goot. It's large volume. It's a GS100. It's basically a plunger, ribbed for your pleasure. I'm a 12-year-old boy. Don't blame me. Blame society. So you pump it. You give it a pump. And it's just too many jokes. Give it a pump, then you press that button, and the little plunger that's spring-loaded flies backwards and hopefully sucks a bit of solder in with it. You can see the tip there. When you push it forwards, that cleans out the solder, any that might be in the tip. Now these tips are supposed to be Teflon. I think this one actually is. Let's have a look. Yeah, so it doesn't melt. Not fast anyway. So yeah, that's Teflon. Some of the cheaper ones just have any old plastic, you know, PVC or whatever. But this is good. This is Japanese, so this is probably as good as you're going to get. So let's see how this one performs. We'll pump it. Remember, we've got our fresh solder on there. Excuse me, my throat's playing up. Heat it right up. Wow, that actually did better than expected. Pushed out a little nipple of solder there. So that didn't clean it as much, but you can see it still evacuated the hole almost completely. So that would probably, with a little bit of extra help from the flux, from the braid, probably the combination of the two would work okay. Let's just do another one close up. The other thing I don't like about these ones is when the tip's got some solder in it and you pump it back and that pin tries to come out, it pulls the end off, and you got to jam it back on all the time. That's not fun either. You got to get right in there. It's a bit difficult. Yeah, see, that one didn't fully evacuate the hole. So now I've got to add a bit more solder to distribute the heat down in the through plated hole. Try again. Biggest issue with these is trying to get the tip where you're trying to get the soldering on as well. Yeah, see, not quite working. I think we just got lucky on the first one. So, just get yourself a desoldering gun, mate. I've got this one, which is sort of the Gucci handbag. Pace. It's just like, if you got all the tools, at least you sort of look like you know what you're doing. Pace is like the bee's knees. There's JLC and stuff as well. JLC? Yeah. And Metcal, all pretty high-end stuff. And then there's Heiko, which is sort of down a bit, but still good. Really, really good value. They've got their high-end stuff as well. I've got an obsolete one here, the Hako 474. That's my second workstation. And that's got the 815 handpiece, the angled handpiece. So I got that on purpose because it's nice to be able to get in corners sometimes. You've got the straight one here, and you got the angle one there. So you should be able to get in a lot of stuff. I know it's sort of, you know, but that area there does make a difference quite often, and you can get down inside stuff. So that's handy. This handpiece is obsolete and the station's obsolete. I got like one of the last runs before I knew they were going obsolete. I probably wouldn't have bought them. Then I searched everywhere and I found a couple of spare handpieces because they all like erode around here, and then eventually they just fall apart. This one's about 5 years, 6 years old though. Probably 6-7 years maybe. I think I got it around 2015 and she's been worked pretty hard ever since. I use this one every day until I got the pace. I was a little bit standoffish with the pace, but now it's the one I use pretty much every day, and it's still a current model. So I've got a couple of spare hand pieces for the Heiko. Nothing will probably ever go wrong. Maybe a new diaphragm for the vacuum pump, but besides that, the hand piece is the main wearing part. And I've got 2 spare ones, brand newies. So they're just in reserve for when that one shits itself. I want to go through all 3 of them. Hopefully I'll be in a position where I can buy a new soldering station anyway. So anyway, back to the job. What's a Brad's Guitar Garage video without a few tangents, eh? A few sine waves, a few tangents. Going back to maths lessons. So you can see how easy this one is. In you go. Melt it. Wait till you feel the lead move. Hit the button. Things like that just make you be able to have a chance in hell of keeping up with the repair queue. Just had a look at the other side, and there's some pretty crusty glue underneath it that's overheated. So I just want to clear that off, because that could become conductive, if not now, in the future as well. Better be safe than sorry. So I'm just jiggling that connector. It came out reasonably easily. And we can see those 2 pins are quite pitted. Let's get some focus happening. I know you don't like focusing, little camera, particularly in your old age, but I have had this camera for a while now. You can see those 2 pins there, and possibly that 3rd one. That's probably the bipolar supply. Possibly that's the return pin, and they're quite pitted. You can see the plastic's discoloured there, and when the plastic discolours, it usually goes pretty brittle as well as it degrades. So I think we should possibly replace this connector. So I'll probably pop one of them on order. We'll decipher what part number actually it is, and maybe we'll get a new connector there too, because that's looking pretty crusty. We'll pop those crimps out and have a look at them one by one, possibly give them a clean, but you can see how yellow the plastic is there. It's not ideal either. Just get something a bit firmer than the plastic pointer. And out she comes. You can see there, it's pretty pitted as well. Right on that contact point there. So we could, you could scrape that back and sand it and stuff, but now you've just gone through the coating, the plating, which is probably nickel, and then it would just corrode. So yeah, temporary solution, but not really a solution. So the right solution is to buy a bloody crimping gun, and get the crimps and get the connectors and redo it. Just gently remove this bridge underneath. It's got the solders let go, but the glue is still holding on. So we'll just push the pins from the other side of the board, and that's making the glue let go a bit more gently, and just pulling it from the other side. We'll flip her over and have a look. There it goes. So yeah, it's got full contact from pin to pin. They've just slathered the glue on there and then shoved the part in. So some of that probably made it to the other side of the board before they soldered too, and that's probably why there was a bit of contamination in the solder joint. Not ideal. You can see down here, that's where the bridge was. That's where the connector was. That's where the cap was. The glue's just in that whole area. Now, if you went to scrape that glue up, see that tiny little cap there, little surface mount bugger? That might go with it. So you got to be real careful. there could be other parts mounted to the circuit board underneath here as well. There isn't in this case, but you don't know that until you've either looked at one before or looked at the PCB layout, which is often not included in the service manual. They'll just have the schematic. So yeah, just be aware of that. There could be stuff waiting to be damaged under the pool of glue. So we've just got to get down there and gently remove the glue residue with tweezers without disturbing the surface mount caps nearby. There's a little bit of residue under where that bridge was, but most of it came off with the bridge, and it's kind of darkened colour compared to the rest of it too, so the heat has affected it. So we'll use a hot air station, just set gently to about 200 degrees, just to soften that stuff up a bit. So this probably turned molten every time the unit was turned on, and then re-solidified every time it got turned off. So it kind of defeats the purpose anyway, doesn't it? So you can move the unit, and it provides shock protection when the unit's cold, not when it's warm. It's gone like a grilled cheese kind of consistency now. Could just chuck a new bridge in if I got one. But I don't think I've got one in this particular form factor at the moment. There we go, that's a bit better, isn't it? So we'll just check there's no more glue residue on the board, clean it up with a bit of alcohol, and I'll reinstall this one. Saves us buying a newie and waiting on the shipping and minimum order quantities and blah blah blah. So we've still got some glue held captive by the leads of this regulator, and that wire just fell off as I touched it. That's the tap tapping into the regulated output there to go to the removed meter calibration board. So we might remove this regulator and just get all the glue residue out from underneath it, and reinstall it and reconnect that wire a little bit more sturdily. While I was moving it around, I just noticed down there more remnants of cockroach. Lovely. Like I say, I'm not really a technician, I'm more of a janitor with soldering iron. So there it is, LM317T adjustable linear regulator. You can see the blob there from the wire that was connected to it, and blob of glue underneath. We'll get rid of that. Alright, we've got the regulator back in place. Now I'll just tighten up its little nut on the bottom side of the circuit board. That's a 5.5mm tube socket, but it's got this handy little grip around the edge of it, so that's more often than not perfectly adequate for electronic stuff. So you don't even have to find the handle, you just use that. Very handy. They're Draper Expert. So now we'll remove the rest of the caps, desolder them all from the bottom. Just got to remove the glue after that. Coming out pretty easily. See, the glue doesn't really do much either, and it lets go pretty easy. That one's a bit stiff still, I might double check that. Feels a bit, you don't want to force them if they're not coming out just with sort of the weight of themselves. If you force them, and it is tempting to just give it one more wiggle, but trust me from experience, you don't want to do that. So now we've got a free board ready for repopulation with the new capacitors. So I'll just go dig them out. We'll clean up the glue. Most of the glue went with the caps on those last few. It looked like a different formula of glue. It's sort of transparent, whereas the other stuff was like a toffee sort of type consistency and look. The stuff's actually moving with a bit of alcohol too, which is nice. Don't have to scrub the board too hard. That's just 99.99% isopropyl alcohol. Don't use the hardware store stuff. It's meant for cleaning windows. It's no good. Too much water in it. We're looking hunky-dory. I'll go grab those caps. Alright, so we've got most of the caps in. We're just putting the last few in. Just checking the orientation. At the moment, supply on everything is a bit touch and go. That's Aussie for shithouse. Actually, no, that's Aussie for touch and go. Anyway, it's not good. So normally I like Nichicon, if I can get it. Vichy for axials, Nichicon for radials. Maybe Nippon Chemicon for the real big stuff, like the big can caps in the old hi-fi gear. But if we had to go with Epcos for the big two big caps here, the 4700s, which is fine. They're 105 degree rated, so, but you know, long life caps. They weren't cheap, but that was literally, I think, the only ones available. And you got to roll with what you got. Not saying they're better or worse. They're probably just as good as Nichicon, as long as you don't go the no-name crap or the stuff from the weird third-party suppliers that no one really knows who they are. Just go through DigiKey, Mouser, RS Components, Element 14, and you'll be right. So we'll pop that bridge rectifier back in, now that I've blocked its path with the cap. And we'll flip them over and start soldering them in place. I hope the death metal in the background's not bothering you. I don't know if you can even hear it. So I've folded all the leads over, but as we solder them, we'll just keep our finger on the other side and just make sure they're 100% bedded in to the board as we just reflow the solder again. But we'll go through and we'll start the buffer. Start, buffer. Thank you. Thank you. So, got the new voice activated one. Just go through, we'll apply solder so it's a fillet, not a big ball. Now these were particularly large pads. It's almost like they set out to use snap-in caps, but when I removed them, they weren't snap-ins. What you'll often find on a bit of gear, well-built stuff, is there might be multiple sets of holes for one capacitor. Because they, even when times were good, supply chain issues weren't as much of an issue as now, they still designed in a little bit of redundancy, so if they couldn't get their primary cap that they liked, they could work with something else. It's a good move, particularly in this crazy time we live in. Right, they're all soldered, so before we reflow them and push them down, we'll just go through and snip off the excess. It's nice to reflow after cutting the leads off, so you can get some solder on that tip of that lead, just so there's no exposed metal. Some leads have steel core on some components, so you kind of want to get a layer of lead or a layer of solder over that raw steel end so it doesn't corrode. Most have copper. Generally copper is preferable. Turn off buffer. Thank you. Don't let these leads fly off. It's a good recipe for disaster. You'll fire up another bit of gear that's open across the room. These will fly 5 meters, 10 meters when you snip them off. they'll end up in a piece of gear you haven't even opened yet. They'll find their way through the vent. They will destroy stuff if you let them. So hold every single one of them. As you cut it, put it in a bin. I've just got an old yogurt container here. And dispose of it. Just resolder that bridge. Oop, forgot the buffer. Now, just go through, hold down each cap, just make sure it's seated. Yep. Yep. No movement there. You want them hard against the board. Alrighty. We can't forget to resolder that regulator we removed. We, as in you and I. You gotta do it with your pinky out. That's how you know you're classy. Gently brush the existing areas and see if we can find any underlying damage. Because there's some a bit of weirdness happening in those areas. Looks like someone's definitely been there before. What exactly they were chasing, I don't know, because it looks like they've just reflowed large areas. Maybe someone's tried to fix this crackling issue before and just ignored the blatantly obvious bulging cap. Cockroach shit, and a few other issues I spotted that I'll show you when I flip the board over. Every chance, because it was over such a large area, maybe they just fluxed the board and then tried to reflow with a hot air gun. Not sure. Need to get the crystal ball out. No, wait. The DeLorean. Crystal ball looks into the future. Looking in the past as well? I don't know. Anyway, yeah, so a few other spots. When I've removed the flux, it just looks like the factory joints underneath actually, so not sure what the deal is there, but anyway. There are a few spots there which have some pretty fat solder joints. Doesn't look like the average reflow. Oop, I spy some cockroach poop. Let's get the air compressor. It's primarily to blow the dissolved flux out from under the chips so we can wipe it up. I'm not hitting it with a lot of pressure. We've got a regulator on that line, so it's not just straight up from the tank. 100 psi, whatever it is. You'd probably blow chips clean off the board if you hit them with that. Just gonna have a close look with the loop. Those solder joints. Someone's been in there probing about too. You can see little holes, little dents in the solder pads, the solder joints. So this thing's played knifey spoony before. Well, here's me soldering the connector back on like a chump, and I just had a quick look at the J-Car catalogue, and it turns out they have these in stock. Who would have thunk it, eh? J-Car being useful for something. So she's on the way home from work, so I'm sending her there to do the walk of shame, and she can drop them off to me on the way home. So we might get this done today, 100%. So while we're waiting for the missus to get here, we'll just check over our other work. So those caps, Very slight movement to them, but pretty damn solid. They're not flopping back and forth. So I'll get a bit of neutral cure silicone and just put a little bead between them, particularly the big ones there, big 4700s, just so they're sort of tied to each other, and that'll restrict their movement quite a bit. We'll go to the one next to it. So if you've got silicone, you sniff it and it smells plasticky, that's what you want. If you sniff it and it smells like vinegar, do not use it, because that's acidic cure, and that is corrosive as shit. It's meant for bathrooms, that kind of thing. So generally, if you keep it off an electrical connection, doesn't matter a hell of a lot what you use. Keep it off metal in general. It's me saying that, and there's a little bit on there, but I'll wipe that off. But this stuff's neutral cure anyway, it's pretty cheap. There's specialty silicons available for electronics work, and they run like, you know, $50 a tube. That's not what the manufacturers use on this kind of application. It's meant for high temperature, high dielectric, strength, all sorts of specialty fields, but just generic neutral cure silicone is all we need for this situation. And I'll stick a little nozzle on there to get down to the small caps. May as well chuck a bit on them as well. Since there's not much room between them, we'll just put a bead between them on the vertical orientation. Just like that. These little tips, you can reuse them. Just let the silicone cure in one. It's good to have a couple on the go. Don't try and clean them out while the silicone hasn't cured, because it won't work for you. Wait for it to cure, and then blast it out with compressed air. And it comes out like a little sausage, a little nipple. If that doesn't work for you, jam a screwdriver down there just to loosen one edge for the air to get somewhere to get its claws in, and that'll blast it out of the tube. All the good tips here at Brad's Guitar Garage. Alright, got my beautiful crimping gun, Pressmaster, made in Sweden. It's funny, it doesn't smell like meatballs. Anyway, so that's got 6.3 mil spade connector die in there that I used last time. I think I was making new crimps for speaker connectors or something. But they look way too big. Look at the size of the crimp there. Zoom in and I'll show you. The seller of the crimps did suggest their tool, but it's a piece of shit, as most of their tools are. I'm not buying a piece of shit just because it says that it's right. So you can see there, you've got the crimp that crimps on the connector, the conductor, sorry. Let me get a pointer. You got the crimp there, so there's two crimps in one. There's one that crimps on the actual conductor, and there's one that crimps on the insulation. Now this isn't the best crimp going around either. You can see there it's sort of gone skew-if, sort of sideways. And you can see there that they take up about 50% of the crimp. Now look at this one. You can see that that is way too big. That's the center line there, so that's one size crimp for the insulation, that's one size crimp for the conductor, and it's massive. So we don't need one that big. So what we do is we close it, we release this little catch, and the super expensive die comes out. And look at the machining on it, like, no wonder it's expensive. So that's it there. Sort of two-piece, but joined together by a stake as a set, and it's laser etched on there what it's for, and it's covered with oil. Protective but annoying. So we've got one that's meant for 2.8 mil spade connectors. You can see there laser etched 2.8, and then it's got the different wire gauges. So that 2.8 is to suit this. You can see the different size. in the width. So I think this is more like it. When we look at that, it's about 50-50, and it approximately lines up with the existing crimp, so I reckon that's what we're in for. So I'll load that up into the gun. Got to close it first, and away we go. Alright, so we've got the die loaded in the handpiece, the crimper. We've already done one. This is the new connectors. The missus dropped them off on the way through, on the way home from work. That's probably the colour that these started out at. You know, they're both nylon. So we've just done one. I thought I'd better show you. So I'll just do another. So we'll release it from the housing as a good practice, just so we don't reduce the cable length any more than required. So that's the old connector. Double check that that is home and happy in the middle position. And it is all good. Now on the wire, any good quality wire will show you its gauge printed on the jacket. It's 300 volt rating. Now it's important to check each wire, because for different currents you've got different wire gauges, so don't just check one and assume all the rest are the same, because chances are they won't be. So that's 22 American wire gauge. So we want to use the 22 slot on the stripper. They'll actually show the wire gauge on the stripper. That's not just for show. So 22 is the second one from the end. We want to take off, I'll just snip the end off a bit, clean it up. We want to take about 1/8 of an inch off. And it's just a nice, easy to remove off cut. If you feel any resistance, you've either gone too far and it's biting into the copper, or not far enough and the jacket's still holding on. It should just go clink and then come off really easily. If not, you probably got the wrong setting. So then the crimps themselves come in a little gang like that. I suppose there's automated machines that do this, as opposed to this meat popsicle. So we just, you can see there's the two, zoom in a bit for this, there's the two little collars. One of them's for the jacket, just to hold on to them, and the other one's for the conductor. So it's going to sit about like that. So I find it's easier to get it in the gun first. Gun, whatever you want to call it. Just take up the slack, get your wire in there. Make sure there's no little pubes coming out sideways. Just check from the other end that everything's about where you expect it to be, and then crimp. It won't let go until you've gone to the last click. And there we go. Crimped. See, it's nice and tight on the wire there, on the conductor, and then it's dug into the jacket as well, so that's a nice crimp. And that goes with the catch face, the little hook there on the back side that my nail's catching there. That catches in this little window. So as you feed it in, you hear a little click. And that's it. Now it's anchored in there into the new housing. So we'll just do that 3 more times and throw out the old one, and then we'll replace the one in the circuit board as well. It is oddly satisfying, I'll admit it. And that's our connector done. See that for some reason they've chosen a 6 position connector on here, but the last one's not connected to anything, so they're only using 5 out of the 6. You can get 5 position ones, so I'm not sure why. Alright, so there's our connector, our header on the board, the new one. So that's good to go, and that's our new connector. Slots down into that. Nice positive, no scritchiness like when we removed it. Now, one other thing I spotted, I'm just going over the whole thing while I've got it apart, because when the diagnosis is crackling or intermittency. It could be literally anything. And I spotted this. So those jackets have pulled back, probably melted from when they were first put in. Those wires aren't very tight in there. The crimps aren't very good. And the wires have the opportunity to touch each other. Now, it looks like there was a ground connected at one point and it was cut. Because you can see the ground wire poking out and you can see that it's removed from there. That's likely on purpose, possibly because that created a ground loop. They might have had an error on the circuit board where that ground is connected to the same ground as this pin that it goes to up here, and it may have created a big ground loop and introduced noise. So maybe they broke the loop by cutting that connector there. And these are the ones that still have one intact. They probably just had a pad there that didn't return the ground or whatever, or the ground was actually supposed to go to that pad. And this one was likely a factory revision. So down there, that's not actually a connector. That's like a pin plug that goes into the circuit board and just gets soldered to the bottom side. So I think we'll remove that, and since we don't have those tiny little crimps or those connectors in stock, we'll just hardwire that connector to the board, because it disconnects from this end anyway. So if you needed to disconnect the two, it just disconnects there anyway, and that side's soldered anyway. So we'll just hardwire it to the board and just clean up that connection a bit. Right, so I'm just going over the whole thing before I reinstall everything, and just noticing. It's just little specks of cockroach crap. It's tiny little specks. May or may not be conductive, but may or may not be an issue at all. So I'm just going over everything with a fine-tooth comb just to see in case there's any corrosion or debris anywhere else on the board. Fun times. So we'll just clean the cockroach turd off the bottom of the chassis as best we can, but you can really see how corrosive it is. Like, it's eaten into the any raw steel. It's just rusted hell out of it, almost, you know, full on pitting. So it's not good stuff. And if you've got cockroaches in your house and you've got audio gear, well, best get your house sprayed as soon as possible and open all your gear and blow it out and vacuum it. Do it outdoors too, because it's biohazard and it's just plain gross. So it's often good practice when you're removing or dismantling a device, bag the stuff up in the order you took it apart in. So even if you don't write a note on it, you can probably still figure out which way you did it. So in this case, that was the last amount of screws I undid. So that was the only ones on video. That was the board and the back cover, and the ground wire over here on the left there. And then you've got a couple of lock washers, 4 lock washers, and 1, 2, 3, 4, 5, 6, 7 screws. So that was for the digital board. That was the second thing I removed. Still got to clean that. Might give it a test run without it first, just to see if maybe that's still causing issues, because there is a fair bit of contamination on that board, as you can see by all those turd snail trails. And then, so that can go with that. And then the last lot of screws was the cover, which are all black screws in two different lengths. So you can either use Ziploc bags. What I also like to do is get Chinese food containers, you know, the plastic things, and put them inside each other, so they all nest into each other. So first box, put it on the bench, put all your cover or your back cover, your back plate, panel, whatever you're working on, keyboard, put all your bottom cover screws in that one. Put an empty one inside that on top of the screws, and then you'll have your, I don't know, your next stage. Like, you might need to remove a circuit board next to get to whatever you're looking at. So that will go in the next container, Once you've done that, put another empty one on top and just stack them up. And then when you reassemble the thing, you do it in reverse, and that is just an intuitive way of going back through your steps in a reverse way. And often you don't even need to keep notes when you do that, but it doesn't hurt to just pull your phone out. I mean, it doesn't cost you anything. Just take a couple of photos at each stage, delete them later, whatever. Hang on to them until the job's done. If you're a professional, save them in the job file so you remember exactly what that job was, what it looked like, what the condition was. If there's any complications later on, someone challenges you, said you did or didn't do something, you can say, well, look, here's the photos I took, blah. So it's good to have a little ass covering measures as well, and that's good for that. I didn't plan for this to be a Brad teaching other techs when he probably still doesn't really know what he's doing himself channel. But anyway, so we're just popping the back cover back on. That's all the black screws, number 1 Phillips. It's easy for you guys because you watched it like 20 minutes ago in the edited video, but I'm not in edited video land, I'm in real land, and things take a long time. If only they were as quick as edited video land, I'd have this done. Just to be able to put this meter offset board back in, and everywhere I look, there's cockroach poop. A bit of alcohol. So on second thoughts, this must have been the plan from day one. They must have just run out of room on the circuit board. Because you can see they've got those little tabs on the metal. They've got corresponding holes. It's not like they just found the nearest mounting hole. It's got a ground plane there. It's got nothing underneath that the bracket will touch. So I think this was the plan from day one. Seems like a strange little implementation, like add-on. Weird. Well, I wasn't in the room when this thing was designed, so I'll leave that up to interpretation. Alright, let's fire this thing up, see how she do. I'll watch the current meter. Inrush at 40 watts, settling down to about 36 watts. Right, so everything's set the same. We've got the same input mic, all the gain switches are set low, and the trim's all the way down at the moment. We've got no response on the digital side because the board's still waiting to be cleaned up. But everything's set the same on every channel. The meters are a little bit off. These two in particular. We're going to see if that's actually noise that it's registering on the meters, or if the meters just need calibration, in which case we'll have to adjust the little meter board down there. So let's pipe it into the ZI8, which is operating as our interface today. And although it's got the digital board, that's only got a light pipe output, or AES SPDIF, as well as the word clock, but I don't have an interface that takes that directly from digital. At the moment, I don't have a optical interface at all, I don't think. I should probably get one of them. I want to get a little interface just for under the bench here, so you guys can hear my beautiful voice with a lapel mic instead of just this overhead cam mic. It's not too bad. It's a pretty good acoustic environment, but background noise and stuff would be nice to have a lapel mic on there. And so I can have a mic under the bench on a test cabinet all the time, ready to demonstrate amplifiers. So I'll probably be getting one of them anyway, maybe a Mo2, and I'll try and get one that's got an optical, just so I can test bits of gear that only have an optical output. Anyway, getting off track as I do. Let's plug this thing in and we'll have a listen.
Hey yeah, hey yeah, hey yeah, yeah. You're currently hearing me through this preamp. At the moment, it's a little bit noisy. I have got a compressor on it as well, though, just so we don't blow your ears out. So that's switching between the gain levels on channel 1, channel 1, channel 1, channel 1, channel 1. A little bit crackly there, a little bit crackle. That's the gain. It's a very quiet preamp, and that's the ambient level of hiss. Ambient level of hiss. It's demonstrating the pickup pattern of an SM58 right there. So she's a nice preamp. You can hear my whistling nose. Alright, so beside the crackle, I think that channel's rather healthy. Let's just test the filter. Hey, yeah. Yep, so that's working. Test the different impedance inputs. Medium, high, low, ISA428. I guess that's the original preamp. Medium, high, low. Alright, let's move on to channel 2. So I'll just turn you down for a sec. Alright, so that's on mic gain at the moment. So this thing's got a stupid amount of gain. Let's just demonstrate that. Hey. Yeah, that's pretty nuts. But again, noise level, pretty respectable. There's a bit of hum there. That's primarily coming from the mic, I think. From the surrounding equipment and its magnetic fields. That's the sound of my soldering station there. Not sound, that's a magnetic field of it. Almost sounds like a dance track. Alright, I think we're good. Let's clean up the digital board and you can go back to listening to the crappy overhead microphone.
Alright, so now we get the fun part, that is cleaning the board, digital board. So we'll see what alcohol will do. Now looks like a layer of flux. You can see the cockroach shit already falling off it. There appears to be a layer of flux on this board still, which actually might help us out, because any contamination will be on that flux instead of on the actual copper or solder mask or solder. So we might be able to clean this off, and the layer of flux is actually protected, the board underneath. So much for me poo-pooing people that leave flux on stuff. I've got a bit on my hand. Jesus Christ, I want to go home. Ideally, organics like this dissolve most readily in water-based solvents, but we don't really want water-based solvents on here because we might corrode vias and do all sorts of stuff we don't want to do, get water under parts. So we'll stick with the alcohol and we'll see where that gets us. It seems to be working, albeit a bit slowly. But what would a job at Brad's Guitar Garage be without it taking an inordinate amount of time due to unforeseen issues? So there we go, that cleaned up alright. A little bit of a haze on it from the ISO, but I'll give it another rinse. But all the residue came off, no real corrosion, so I think we'll be fine on that one. I dare say there would have been crosstalk between traces that aren't supposed to be talking, just by the scale of the contamination. So there's no way that could have been good for the thing, but yeah, I think it's pretty likely that that would have been causing glitching and all sorts of weird behaviour as well. So I guess we'll plug this in and we'll check out the analog output, see if that is affected at all by having this installed, and if not, we'll give it back to the customer and we'll see if he has any effects, and we'll just say, look, don't have an interface at the moment which takes these formats, digital format outputs, but plug it in, and if you have any issues, give us a yell and we'll go further from there. But we'll just plug it in and have another quick test. Another quick note on reassembly: if you haven't marked, exactly which screw goes in which hole, there's just hints that you can use. Okay, well, one of these screws has a bit of surface corrosion on it and one of them doesn't. So chances are that one was inside the chassis and that one was on the rear panel. So set that one aside. Chances are they might be the same screw, but there might be a slightly different head size or whatever. You've got a certain amount of screws, you've got a certain amount of lock washers. Well, where's the lock washer left a mark? It's left a mark here, so we know that there was a lock washer there. Assuming it was there from the factory and no one had played with it and put it back in the wrong place, you can be pretty safe to assume that that's where the lock washer goes. So I was about to calibrate the meters and I realised with no power applied that they're out. So these are mechanically adjustable, they're 0 point, but the adjustment screw is behind this steel panel. And to get to that, you've got to undo these screws, you've got to undo those pods, you've got to take that switch out, you've got to remove the front panel, you've got to remove the screws across here, you've got to take the panel out, probably remove some wires, maybe unplug all those meter offset wires. You've got to take this panel out, you've got to unscrew that whole front panel. You've probably got to make sure that none of these buttons fall away. You might have to take the knobs off. It's a massive job. It's probably another hour and a half just to adjust those meters. So I'll make the customer aware of it and just say, look, it's going to cost a fair bit more because it's a fair bit more time, and time is money. And do you want to live with it, or do you want to look at doing that? So I'll leave the option to him. Alright, so I'm now content that this unit is happy. I'm going to stick the cover on, get it back together. It does have a ground wire here, just to make absolutely ultra mega super sure that the cover is grounded, even though it's got masking on all of the fixing points on the chassis. Bit of an overkill if you ask me, but hey, who am I to judge? So we'll just give it a bit of a clean up on the top of the lid. A bit dusty, a couple of scratches, we're not going to worry about that, but we'll just get the grunge off. Plenty of it on there. So there you have it, champions. She lives to fight another day, despite the cockroach assault. So it may not be as sexy as the big hot tube amp videos, but in my opinion it's just as important and just as interesting, but I'm weird like that. Anyway, see you on the next one. Have a good one, champions.